Assalamualaikum and hello everyone. So today we are going to discuss tutorial question chapter 1 number 7. Figure 6 shows charge 1 which is 5 microcoulomb, charge 2 which is negative 4 microcoulomb and charge 3 which is 4 microcoulomb in XY plane. Alright, the question asks us to determine the magnitude and direction of the net electric force on Q3. We are going to look for the net electric force on Q3. Alright, so the first step, we are going to label the charge. So charge 1 is positive charge. So here is positive. Charge 2 is negative charge. And charge 3 is positive charge. Alright, the second step, we are going to draw the electric force diagram. We are going to draw the electric force diagram on charge 3. So we are going to draw electric force diagram on charge 3. So if you look between charge 1 and charge 3, they have the same charges. Both is the positive charge. So they are going to repel. So if it's going to repel, we are going to draw the arrow away. Okay, kita akan draw arrow dia jauh daripada charge 1. So this is your force of charge 1 on charge 3. Okay, so that is between charge 1 and charge 3. Okay, let's look between charge 2 and charge 3. Charge 2 and charge 3 have different charges, which is positive and negative. So if they have different charges, they are going to attract. So if they are going to attract, mereka akan bertembung lah. So the charge, the force is going to be like this. So this is your force you feel of charge 2 on charge 3. Okay, so that is our second step. Our third step, we are going to look for force of charge 1 on charge 3 by using the electrostatic force formula, which is K Q1 Q3 over distance between charges squared. So distance between charge 1 and charge 3, we squared it. So K is the fixed value, which is 9 times 10 to the power of 9. Alright, and then charge 1 is 5 microcoulomb. So I'm going to change the unit to coulomb. And charge 3 is 4 microcoulomb. Same goes to it, I'm going to change the unit to coulomb only. And the distance between charge 1 and charge 3 is 32 cm. And I'm going to convert centimeter to meter, then I'm going to square it. So you will get your force of charge 1 on charge 3 is 1.76 Newton. Okay, so now we are going to calculate for force of charge 3 on charge 2. So we are going to calculate the electric force of charge 2 on charge 3. So the formula is still same. K charge 2 times charge 3 divided with distance between charge 2 and charge 3 squared. So as I told you, K is a coulomb constant and the value is fixed, which is 9 times 10 to the power of 9. And the charge 2 is 4 microcoulomb. We will not take the negative. And charge 3 is 4 times 10 to the power of negative 6 divided by the distance between charge 2 and charge 3, which is 36 centimeter, and I will change it to meter. Okay, so there's a typo here. 9 times 10 to the power of 9. Alright, so if you press the calculator, you will get the value of 1.11 Newton. Okay, so our main purpose is to find the electric force on charge 3. So we are going to look for F3. Now we have F13 and F23. So what we need to do, we need to resolve it. Okay, we need to resolve it. So in order to resolve it, please remember your chapter 1, semester 1. So now I'm going to draw the axis. So this is your x plane. So this is your y-axis. So at y-axis and x-axis. Okay, so where should I put the angle? As you can see, this is Z. Okay, ni Z, bentuk Z. So kita tahu kalau bentuk Z, the angle here will be the same as here. So this is 72 degree. And the angle here will be the same as the angle here, which is 72 degree. Remember. So this is mathematics. And where should I put the angle of 56 degree? Same goes to it, Z. So ini bentuk Z kan? So the angle here, 56 degree here, will be the same as the angle here, which is 56 degree. So what I'm going to do, I'm going to redraw this. Okay, I'm going to redraw this. So this is your y-axis and this is your x-axis. So y-axis, x-axis, and your F13 is here, and your F23 is here on the fourth quadrant, and the angle is here 72 degree, and the angle here is 56 degree. So now we are going to resolve it. Okay, we are going to resolve it. So here will be F13x and here will be F13y, and here will be F23x and here will be F23y. So I'm going to resolve it and put it in the table so that you can see better. So force, the unit for force is Newton, and we will have x component and y component. Okay, let's do one by one. So we'll do F13. So F13x will equals to F13 cos theta. So why? Because your angle is at x-axis. Okay, dia melekat dekat x-axis. So dia champion. So dia adalah cos. So F13 we already know the value. The value is 1.76. So 1.76 cos 72 degree, which you will get 0.54 Newton, right? Then let's do for y component. So F13y equals to F13 sin theta. So dia akan opposite je lah. So F13, F kita punya force is 1.76 sin 72 degree. So if you press the calculator, you will get 1.67 Newton. Okay, so that is for force of charge 1 on charge 3. Okay, let's do for force of charge 2 on charge 3. So F23x equals to F23. So the angle is at x-axis, that's why dia adalah champion, dia adalah cos theta. So F23x equals to F23 is, we already calculated, which is 1.11 cos 56 degree. So if you press your calculator, you will get 0.62 Newton. Then F23y will be F23, but it will be in negative because dia adalah negative y axis, so negative sin theta. So F23y, which is negative 1.11 sine 56 degree. So you akan dapat negative 0.92 Newton. So now we are going to look for submission of force. So submission of force for X component will be 0.54 plus 0.62 Newton, which you will get 1.16 Newton. And submission of force for Y component will be 1.67 Newton plus negative 0.92 Newton, which you will get 0.75 Newton. Alright, so we are done. So now we are going to look for the magnitude, for the net force of charge on charge 3. We are going to look for net force on charge 3, net electric force on charge 3. So we are going to use this formula, summation of force in X component squared plus summation of force in Y component squared and square root it. So summation of force in X component is 1.16 squared plus summation of force in Y component is 0.75 squared, and square root, you will get your answer 1.38 Newton. And remember, we are not done yet. We need to look for the direction. And remember, in order to look for the direction, the formula will be tangent theta equals to summation of force in Y component divided by summation of force in X component. So your Y component is 0.75, your summation of force in Y component, and your summation of force in X component will be 1.16. So rearrange the equation and press the calculator. You will get the angle shift tangent equals to 0.75 divided by 1.16, which you will get 32.88 degree. Remember, we are not done yet. We need to look where is the force, which quadrant the force at. So we know we will have Y component, X component. So this is the first quadrant, second, third and fourth quadrant. And remember, first quadrant, X is positive, Y is positive. Second quadrant, X is negative, Y is positive. Third quadrant, X negative, Y negative. Fourth quadrant, X positive, Y negative. Okay, let's look. Submission of Fx is positive, so it is positive. Alright, so it will be either quadrant 1 or quadrant 4, and your Y component is positive as well. Therefore, your force is on quadrant first. So this is your electric force on charge 3 in quadrant first. So it is above positive X axis. Why? Because both force in X component and Y component is positive. That's why it is on the first quadrant, or we say above positive X axis. So you can write a conclusion, which is net electric force on charge 3 is 1.38 Newton, which the angle is 32.88 degree above positive X axis. That's all.